Hello students, this is Amuda R, Assistant Professor from the Department of Robotics and Automation. Our subject code is MR3491. Our subject name is Sensors and Instrumentation. So today we are going to discuss about the sensor in the Unit 4 as Part 3. Okay, is acoustic sensor and also a radiation sensor, flow and level measurement sensors. Okay, so these three sensor we will going to discuss. So first one is the acoustic sensor. Acoustic sensor is nothing but our human ear. Okay, in our day-to-day life we are using a mobile phone, right? So that have the microphone. So that only we will say something from our mobile. Somebody can hear our voice. Okay, so by using that microphone only. So this is processing circuit. This is some processing circuit. This receives the sound signal. This receives the sound signal from the free space or air that converted into the electrical signal. That is called as a sound sensor. That is sound signal is converted into the electrical signal. That is called as a sound sensor. The output of the sound sensor that can be maybe analog or a digital output. If I say something to you, so you heard what I told means that is called the analog. Okay, that is called the analog signals. So which is easy to use for using this sensor, which is very easy to use and also a cost effective, and also it consumes a low power, also compatible with the standard controls, and also it uses the analog and digital ICs. So the sound sensor is a module that monitors and detects the sound signals like voice, claps, snaps, knocks, etc. So the sound sensor detects these types of signals only. Okay, so it's also known as a acoustic sensor. That movie sound sensor, acoustic sensor, these are all the same only. So we can call it as a sound detector. So which is used in various applications like a security system, warning system, radios, telephones, mobile phones, computers, and consumer electronic appliances, etc. Okay, so the construction of a acoustic sensor, it have microphone, power amplifier, and output actuators. These three components it have mainly. Okay, the microphone act as a input sensor, that is which receives the sound signal and converts into the electrical signal. Okay, then this signal is amplified by the power amplifier. So its amplitude is detected by the peak detector. It have the peak detector, the amplitude is detected. That may be the coming the analog signal coming from the microphone, which have the amplitude is low, means we have the sound that range will be less. We received the range will be less. So it increased the amplitude, then it gives to the output actuators. So for example, output actuator means it's a motion, maybe it's a loudspeaker. Okay, we can call it as a speaker. So converts this amplitude electrical signal into the sound signal for listening. So there is a three main component. One is a microphone, another one is a power amplifier, another one is a output actuators. Okay, here so the range for a microphone is 50 Hz to 10 kilohertz. So which operates with the sensor detector module for detection. Okay, so for this hardware component which is used for high precision, that is LM393N. It's a IC. So this device is mandatory to digitize the electrical signal to digital output D0. So to adjust the sensitivity of the digital output D0, the sound sensor module contains the built-in potentiometer which adjusts the voltage. Potentiometer used to adjust the voltage That's why they are using the potentiometer to adjust the output signal, that is the digitized electrical signal. So the basic working principle which is explained below. So this is acoustic sensor. This is the diagram. Here is the battery. So in the output section, audio output for preamplifier. So this is the backplate and a resistor. These are the construction of acoustic sensor. Here it is the chips. If we are purchasing some acoustic sensor means it will be like this only. Okay. So black diagram of so this is the some our input, our source to the microphone. I say something and then recording through this means the microphones receives our voice, and that voice is going to analog electronics. This analog signal is give it to a data acquisition. Data acquisition means that in that analog to digital converter, and the signal is processing in a data acquisition. Okay. So then and also the amplitude will be increased in the data acquisition blocks only. Okay. So the amplitude will be increased and the noise will be reduced and rejected the noise. Then this will be gives to signal analysis. After that it gives to actuators, that is the speaker or anything. For listener, we give the output to listener or some display or some presentation. So we'll give to that black. So this is the black diagram of the acoustic sensor. Next one is a flow and level measurement. We measure the flow and level which is a technique to measure the level of surface inside the tank. Inside the if I want to measure the water level in our tank means I have to use some sensors. So that sensor is called a flow sensor or level sensor. Okay. So for the safety and profitability of any industrial process, it's essential that plant must have a reliable and precise level measurement system. If my tank having a 5 liter but it measures the 4 liter means it's not a precise output. So I want a precise output. So for that we use the good sensors. Okay. So why level measurement is important? 3 purpose. One is inventory, another is a process efficiency, another one is safety. For what is inventory? The main purpose of level measurement is to measure the inventory in order to keep track of materials in terms of volume or weight. So we have to measure how weight it will be there and how volume is there. Next one is a process efficiency. So accurate level measurement can increase the efficiency. So that is very important. Next one is safety. Inaccurate measurement can cause the problem, right? So such a low level can cause the damage to equipment. So while high level can cause the overflow. So the potential creates safety problems. So we have to maintain the safety problem. So when measure that volume or weight, so we carefully measure with the process efficiency. Okay. So these 3 are very important to measure the level or flow measurement. So for the actually measurement technique, there is a 2 level measurements are there. One is a point level measurement, another one is a continuous level measurement. Point level measurement means it measures how much weight or how much level it will be there, the water will be there. Okay. That measured and it gives the output, that's all. That is, it measures the preset levels or liquid, slurry or solid media. So for a desired set point, already it gives the point as desired one, but in continuous level not like that. It continually it measures the levels of solids, liquids in a storage tanks and vessels. It's continually measured. It's a automatic device. Okay. The sensor used for continuous level measurements are continuous level radar sensor, guided wave radar level sensor, hydrostatic transmitters. Like this, there is a lot of continuous level measurements are there. So next one is a radiation sensor. Radiation sensor is nothing but it measures some lights, radiations. Okay, radiations and the lights from the sun. and another the solar radiation flux density. So these measure the lights. So it works by measuring the number of small units of light. Okay, it's known as a photons. So this impact a physical or chemical devices which is located in a instrument. So solar radiation sensors are typically not powered due to fact that components located in the device either are influenced by or react the solar radiation in direct manner. So next one is a range. It uses the 400 to 700 millimeter range, and also it achieves the 3500 nm range for sensing the radiation. Okay, so this is the structure of the radiation sensor, which have the hot end. Okay, which have the hot end. This is the reference section. So reference junction. So we have to compare the reference junction and for getting the correct input in a particular range, correct output in a particular range. So it's a gold plated copper substrate in below. Next one is the insulating layer. Then only there is a strip which have the reference junction, and another one is a thermoelectric material. In the hot end we get the output. Okay, thank you. Today we discussed about radiation sensor, level sensor, flow sensors, and also acoustic sensor. Three different types of sensor we discussed today. Thank you. If you have any doubts, please drop the comment below. For more lecture videos, visit our website smit.edu.in, and also our Facebook page SMIT Chennai, and also our Instagram page SMIT Official Chennai. Thank you.